Good morning, class, and welcome to this lesson on Fluids 3, Absolute and Gauge Pressure. Today we will define gauge pressure and absolute pressure and give conceptual examples of each. So we're going to start off with absolute pressure. Absolute pressure is the pressure of all fluids in a system, and gauge pressure is the pressure minus the pressure of the atmosphere. Let me give you a common example. Let's take a wheel on a car. Okay, we have a wheel here on a car. Okay, now inside this wheel, I'm going to say that the pressure inside is approximately 250,000 pascals or 250 kilopascals, okay? That is the pressure of the air inside the tire. Is that absolute pressure or gauge pressure? Well, that is really gauge pressure. It is gauge pressure because it is just the pressure of the fluids, the air, inside the tire. If we combined the pressure from the outside air or from the atmosphere, we would add another 100,000 pascals or another 100 kilopascals. So we would have 350 kilopascals for the absolute pressure. The absolute pressure includes the atmosphere and the pressure of the fluid. So it's a combination of both. So if we go back to our original equation, P equals P naught plus rho GH, this P here would be the absolute pressure because we're including the atmospheric pressure. And if we did P minus P naught equals rho GH, then this is the gauge pressure. This is the gauge pressure because we are subtracting atmospheric pressure, and this just makes sense. This just makes sense. Right now I'm standing in a room. I'm standing in front of a board in air, and there is pressure that is being exerted on my body right now from the air, and then there is fluids inside my body exerting pressure back out against the air, and so it feels like it's an equilibrium. It feels like nothing. So if it feels like nothing, let's call the pressure in the room 0 because it feels like nothing. So anything that's above or below this number is what I'm concerned about. I have a bike in the room right now, and the pressure in my tires is approximately 100 psi, 100 pounds per square inch. That means it's 100 psi above atmospheric pressure. Because if it was at atmospheric pressure, it would just be regular old air and it would be a deflated tire. So gauge pressure really is the pressure above or below atmospheric pressure. And I need to distinguish that because that's really when things happen. If every day is normal at sea level, at atmospheric pressure, we're concerned about when the pressure gets really high and the pressure gets really low with that change, because this is the environment that we exist in. So absolute pressure versus gauge pressure. And you can tell this is from the equation that we just learned in the last video, Fluids 2. So there's a couple pictures I want to show you out of your book. This is a barometer. It measures pressure. Up here is a vacuum chamber, okay, empty. This is what we call P1, and this would be called P2. So P2 equals P1 plus rho GH. Well, P1 this is empty, so P1 is equal to 0. So P2 is equal to rho GH. So really, the height of this column will be able to tell me what the pressure is outside. This air pressure is pushing down on this fluid, and because it's pushing down, remember, pressure is exerted in all directions. It's also pushing up right here. So the air pressure from outside pushes down, which pushes it up the tube. There is nothing up here pulling the tube up. It is only the outside atmospheric pressure pushing it down. And so depending on how high this goes will determine the pressure outside. And these increments are typically in millimeters, and this fluid, at least it always used to be, was in mercury. That's why one of our units for pressure is millimeters of mercury, and 1 atmosphere, or standard atmospheric pressure, is 760 millimeters of mercury, meaning this is 760 little notches up to the top where 1 atmosphere would be. So this is an example of the equation being used, P2, and P2 really measures the atmospheric pressure because of how the equation was set up. This is called a open tubed manometer. It measures the pressure of this fluid or this gas inside this container. So when this container is empty or there's no pressure, these fluids here are level. And when this exerts a pressure greater than the atmosphere, because the atmosphere is pushing down here, and this one's pushing down here. So this is like P1, and this is P2. So P2 equals P1 plus rho GH. Well, how do I figure out what the difference is? Well, P2 minus P1 equals rho GH. And if I solve for H, if I know what H is right here, I now know what the pressure is inside. I don't know what the pressure difference is because P1 is the atmosphere. So whatever the difference is going to be the pressure inside here. So this is an example of gauge pressure because P1 is the same thing as P atmosphere. So we're taking the difference between the fluid in this box and the surrounding atmosphere. One more picture here. I know this is not how a stethoscope really looks. It is not usually attached to an open tube manometer here, but it's meant to show the example that when you have a stethoscope, you have the atmospheric pressure pushing down. You have the atmospheric pressure pushing down here. And then you have the pressure of the fluid inside here pushing on the other end. So this is like P1 and this is like P2. And so P2 minus P1 equals rho GH. So this is the gauge pressure. We want to know what the pressure is inside your body. We don't really care about what the pressure is inside your body and the air. We just want to know the difference. P2 minus P1, P2 minus P1 is equal to rho GH. So absolute pressure and gauge pressure are both related. Absolute pressure includes everything, and gauge pressure just includes, or it subtracts the atmospheric pressure because we just wanted to know what the pressure difference is above or below the atmosphere.